Okay, on this example, we're translating a graph from F to G. So the difference is, on the previous examples, we were translating it from x squared, the parent function, to the new function. But what's different here is we're starting at f of x, which is an already transformed function. So like this one already is gone left 4 and down 3. But we're not talking about what happened to this. We're talking that this is the original, and we want to know what's going on right here. So we are only discussing this, and this is written in function notation. So look at our transformations chart. Right here we have function notation, so we're going to look for something similar. So this says f of x minus 2. Note how the minus 2 is on the outside. So it very much looks like this one, f of x minus 3. So that's a vertical translation down 3. So ours is a vertical translation down 2. And I'm okay if we just write down 2. Now, we did this back in 8.2. So this is something we've done before. So we're going to write g in terms of x. So I'm just going to write g of x equals f of x minus 2. I'm just copying that down here. So f of x is our equation right here. So I'm going to take that, I'm going to plug it in instead of f of x. So I'm going to have x plus 4 in parentheses squared minus 3. And then I still have, that's the f of x, I still have the minus 2. So now you simplify that. So you have the negative 3 minus 2 turns into negative 5. And that is your new equation. All right, we're going to try a whole bunch of these. I didn't make you graph any of them because I feel like overall we're pretty good at graphing. But I think this is definitely a part that we could use some practice on. So let's do this again. So on this one, it says g of x equals f of x plus 6. So notice how the x plus 6 is inside the parentheses. So that looks very much to me like this, the f of x plus 1, and that was a horizontal translation left 1. So I'd say if we go back here, we can put that it is left 6. Okay, now I think these are almost harder to write. They're not bad by any means, but just we really have to pay attention to what we're doing. So when you see it like this, where the x plus 6 is inside the parentheses, we're just going to make ourselves a note. X plus 6 is inside the parentheses. So replace x with x plus 6. So you're going to take your equation. So you had g of x equals, and you are going to take this equation right here, and you're going to replace the x with x plus 6. We have 3, and then in parentheses, we had x minus 2, but we're replacing the x with the x plus 6. You still have the minus 2, you still have squared, you still have plus 1. All right, so that simplifies to 3, and then in the parentheses, x plus 6 minus 2 becomes x plus 4. And then you still have squared and plus 1. And that's what your equation looks like. So the difference here is being in the parentheses versus not in the parentheses. So back here on A, the f of x, the minus 2 was not in the parentheses. So where f of x was, we literally just put the f of x equation and then the minus 2 and simplified. I think the vertical translations are easier. Then on this one, because it showed the x plus 6 in the parentheses, when it's inside the parentheses, you take that and you replace the x with x plus 6, because instead of f of x, it's f of x plus 6. That's telling you replace that with x plus 6. So right there, instead of x, we have x plus 6 right there. Nothing else changed. The 3's there, the minus 2's there, the square, the plus 1. And then you just simplify the 6 minus 2, and that's where the 4 came from right here. Okay, so look at this one. So remember, you're only describing here. You don't need to describe over here on the original the negative, the 2, or the negative 3. So it's 2 times f of x. So look at your chart. That to me looks very much like this right here. So that was a vertical stretch by 5. So ours is a vertical stretch by 2. So what we do there is we're taking 2 times f of x. Now 2 times the entire function. So we are going to do 2 times this is all of f of x. So negative x plus 2 squared minus 3. Now when you're doing this, the 2 can multiply in front of those parentheses. The 2 times that negative becomes negative 2. The 2 can't go into that parentheses squared. It's locked up. But the 2 does multiply over to the negative 3. 2 times negative 3 is negative 6. So distribute in front of the parentheses, and if there's a number after the parentheses, but don't distribute into the parentheses, okay? You can't do that. That's going to be similar to this next one. So on this next one, all right, look at what it is. It's g of x equals negative f of x. That negative tells me it's a reflection. If we go look, it very much looks like this right here, which is a reflection over the x-axis. So we're going to write that down. Reflect over x-axis. Okay, so how we write that? I'm just going to write down that g of x equals negative f of x. I like to see that written down. It just helps me be like, okay, am I doing it right? So you have the negative and then f of x. You're going to take this was f of x and you're going to plug it in right there. 3 times x plus 2 squared plus 5. Now you can distribute that negative to the 3 and to the plus 5. You can't distribute it into any parentheses, okay? No distributing into parentheses that are squared. Those parentheses that are squared are kind of like locked up. You cannot distribute into a parentheses squared. Don't do it. So you take the negative and distribute to the 3. There's the negative 3. And the negative, distribute to the 5. There's the negative 5. Okay, and then this parentheses x plus 2 squared, you don't distribute in there because when it has that exponent outside, that is essentially saying you can't distribute into this parentheses until you actually like go through squaring everything. Okay, so don't try to do crazy things like that.